We're gonna be using what we learned about the relationship between a rate or a change in rate uh, and how much there actually is. So we went over how the velocity, a change in distance over time, we could essentially find out that the area underneath the curve of that gives me the actual displacement of the object, right? So we learned that in the last video, but now we have that we're going to learn for really almost anything, right? So we're talking about here now barrels per hour. So at 6 hours, right, you see that they're producing about 100 barrels per hour, right? So at the 6 hour mark, the rate at which they're producing these barrels is going to be 100. So they're doing 100 barrels per hour at the 6 hours, and it's close to 100 for this entire time period, right? So from the beginning, from time zero, they're doing about 100 barrels per hour. So after this one, right, after 1 hour, they've done 100 barrels, and then after 2 hours, right, they've done 200 barrels, and so forth and so forth. And it should make sense to say that after 6 hours, this area here is 6 times the 100. This area right here is going to be about 600 barrels were produced. And you just really want to find out the area for this whole thing, and that'll give you a sense of how many barrels there are. And we just need to approximate that. So I'm approximating this area 600. Then I'm going to say that this area right here, right, is about the area of this triangle right here, right? And this one is very, if not perfectly symmetric to the other one, so these two areas will be equal. And then we should see that this area is exactly 600, right? So, and then this area is exactly 600 as well. And then you should see that this is approximately 100 barrels for this remaining 6 hours here. So this is also about 600. So now what do I get? So let's see. So this is 600. This is 600. And then this is roughly 600. It's a little bit under 600. So we can remember that right now I have an underestimation. It's not going to be 6, 12, 18, 24. It's going to be a little less than 24. But okay, that's fine. Let's see if that matters at all. Now this triangle over here, I can't really tell whether it's an underestimation or an overestimation, right? We want this triangle, this blue triangle, right, is compared to the pink, which is really right the area underneath this part right here. So there's some there's some excess pink here, but then there's an overshoot of the blue over here. So that might actually even compensate, because you want to think, right, the this is probably too much, the blue, the triangle in both of these, right? It's probably too much of this area. So okay, so let's see what's the area of these triangles. This is 6, and then this height is 100. So 600 divided by 2 for the area of a triangle is 300. And then this one's 300. So the total is 600 here. So then now this piece is 600. And then this whole thing is 600. Sorry, this whole pink part is roughly 600, right? By using the triangles. And now I have 600 times 5 is 33,000, right? And that's a good estimate for what the question is asking, right? So if you want, go back, read this one again. Let's see what we have. So the flow of oil in barrels per hour through a pipeline on July 9th is given by the graph shown above. Of the following, which best approximates the total number of barrels? So this is like the amount of barrels, the change in the number of barrels that have passed through the pipeline that day. So what is that value? How many barrels have been produced in this day? And again, that's just going to be the area under the curve of my rate of change function. So my rate of change is barrels per hour, right? Or the amount of change per hour, right? The amount per hour, barrels per hour, right? The rate. I integrate, or I take the area underneath this curve. And I estimated this area, try your best with estimating, to be about 3,000. And that's how many barrels will pass through the pipeline on that day. Now, a similar one, very similar, is this here, where it probably has a little bit better of a relationship to, a rate of change, and then over a time period gives you distance, right? It's just the velocity of a car. So the graph above gives the velocity in feet per second of a car between 0 and 8 seconds, where t is time in seconds, of the following, which is the best estimate of the distance traveled by the car in from t equals 0 till the car comes to a complete stop. So here's it coming to a complete stop. The velocity is 0. And what I'm going to do here is I'm going to draw the straight line connecting these 2 points to illustrate that if I want an approximation for the area, it's not too bad to approximate the area of this triangle. Why is it not too bad to approximate the area of that triangle? Because if you notice, right, the area of this triangle, right, it's very close to the area of the underneath the curve. So if I look at the curve in orange, right, the area that I'm gonna be missing out in this piece, right, so this area is not part of the area of the triangle. It's roughly equal to the area that I'm gonna overcompensate right here. So these two areas, the pink and the orange, are pretty close to each other. The orange is a little bit more, right? So if we wanted to get a sense, right, of whether this is going to be an overestimate or an underestimate, just ask yourself which one's greater, the area that I'm neglecting or the area that I'm overcompensating for, right? This is too much. This area here, this pink, right? That's part of the area in the triangle. So imagine the triangle. The triangle's here, right? This triangle is this pink triangle. The area underneath the curve isn't including that pink part, right? It's just including this orange part, the area underneath the curve. So that's this part, right? And if you look at this region, right, this first region that I shaded in orange, this first region, right, that's not part of the triangle. So I'm neglecting that part. But I'm compensating a little bit for this piece here. But I think that the orange part is a little bit greater, which makes my area of the triangle estimate to be a little bit of an underestimation, right? So the actual area or the actual distance that this car travels is going to be a little bit more than that area. So let's go ahead and compute the area of this triangle here. So this triangle, right? Let's do it in blue so it's very clear what triangle I'm talking about. It's this triangle right here, right? And again, I just use my formula for area of a triangle, 8, right? This length is 8 from 0 to 8. And then 50, 8 times 50 is 8 times 50 divided by 2 is 25 times 8 is the area of this thing. So it's 200. But now I have to remember that this is a little bit more, that I'm neglecting this piece, right? And I think that that piece is a little bit more than what I overcompensated for, which was this piece. So I think it's going to be a little bit more than 200, and I'm going to go with 210, the actual area underneath that curve. That's basically the idea here, okay? You just need to know that the area underneath the rate of change is going to give you the actual amount that has changed, okay? The actual amount. So the amount that's changed here is, what did the car go to? And what is the best estimate of the distance that the car traveled? 210 feet. That's the amount.